about to proceed with Lab3, and I would like to give the word to Engineer Timothy. Yeah, okay. You have the
ストップしちゃっていいかな。
Okay, fine, let's start. Good afternoon. Those that are still doing something, I think can we wind up so that at least we can move on the other section. You'll finish up before maybe you start the other subsection. This is command data. So my name is Timothy Kouama. I've once introduced myself, but I'm going to deal with the command and data entry. So I'm going to give you an rough rundown of what to expect in this lecture. I expect you to have an understanding afterwards of the subsystem overview, understanding the requirements and the functions of command and data handling, understanding the physical architecture, and also how to select a component when you want to develop a satellite for the command and data handling. You also understand the requirements and the functions of the HEPTA-Sat components, and understanding the verification of each item. Alright. So there are two keywords here. We've got the command and we've got the data entry. So the satellite, it has to receive some commands from the ground station for it to do something. At the same time, it has to manage what is happening in the satellite, because the command and data handling is the brain of the satellite. It manages all the information that is being distributed to different subsystems. For example, my colleague, he talked about the issue of power, generation of power. The power is distributed to all the other subsystems. But there was one lab where you were doing, changing the brightness of the LEDs. You saw that one. That lab, the motivation that was there was the issue that when the satellite is moving in orbit, it has to have the altitude determination and control. So the supply of power will be varied. As it tries to move out of the orbit, you need to put a little bit of power so that it comes back. When it is moving okay, you need to put little power. So that lab, the motivation was trying to simulate that kind of scenario. That was the motivation. And also there was another lab that you did that was having for you to press a character. Press a character once, twice, up to about 9 times. The motivation of that lab was you to understand that you are able to send a command to the satellite. So here we've got the ground station where if you press, you send the command to the satellite receives the command, it has to do something, it has to manage what is it that is the instruction saying for the satellite. Maybe it sends a command, it says, okay, you need to take a picture, so it needs to process the information in satellite and it takes the picture, and the picture needs to be sent to the ground station. That is the handling part of the satellite. So when the satellite is moving in orbit, we've got, let's say, a window. Let's call it a window. The time that we are able to communicate with the ground station. It's not all the time when we are able to communicate with the ground station, depending on the orbit. If we are in low Earth orbit, we've got almost 10 minutes to be able to communicate with the ground station. Medium Earth orbit differs, the geostationary 24 hours. But in our case, in the low Earth orbit, there is some time when we need to communicate with the ground station. So when we are not able to communicate with the ground station in time, it will be taking picture. By the time when we have the visible range, we need to download information to the ground. So the satellite takes a picture, it stores in a memory card or memory. Then at the time of the visible range, you need to send the data. So this is what happens in a real satellite case. We've got the ground station and we've got the wireless medium to the satellite, because the satellite will be in space and we've got the ground station. But in our case, for the HEPTA-Sat, we've got the HEPTA-Sat, we've got your wired cable and your PC. So this HEPTA-Sat is representing the satellite in space, and the cable is representing the media for the wireless transmission. At the same time, your PC will be the ground station. So, okay, the demonstration, I think I'll show it later. So in your boxes, you've got this card. That is for the microcontroller. Because the microcontroller is acting as our command and data engine. The microcontroller, this is the brain. So it has got pins on the microcontroller that are assigned to different interfaces. So it manages the pins, the speed, because at times you need to communicate fast with another subsystem, also the amount of data that you can push through the memory that you want, the clock speed for the timing of the information that you'll be sending. So you have this kind of card. So I'll talk of the different interfaces this in the next slide. But I just wanted to make you understand that we've got different pins. You did one experiment on the oscilloscope when you connected, I think, pin 13 and the ground. When you wanted to see the serial communication that is happening from the embedded program that you had put there, you had said serial, pin, whatever, pin 13 and another pin. So the pin assignment, the command and data handling, it manages the pin assignment, because as you can see, there are so many things here that will be connected to different subsystems. So it needs to manage the information that will be distributed to different subsystems. Okay. So the communication interfaces, we've got two. We've got the serial communication and we've got the parallel communication. Long back, the parallel communication was very famous because it was used to send data forward, to push a lot of data. But with the advancement of technology, serial communication is now being able to push also data with very good rates. But in serial communication, we've got two types. We've got the synchronous type and the asynchronous type. The difference is that for the synchronous type, when you're sending your data at times, you want to make sure that the data you are sending, they are in sync. So there's a clock that makes sure that the data is in sync. So here there are two types. We've got the SPI and the I2C. The SPI, you've got four, and one of which is the clock, and three is the data. Then for the I2C, you've got the data and you've got the clock line. For the asynchronous, you don't have any clock. Okay. So here, this is also trying to give you more insight about the interfaces, because they are very much important in terms of the command and data. Because these different pins that I showed you earlier on, you want to connect maybe a sensor, a different sensor for a certain mission, which might be an analog sensor. But some analog sensors, they produce a very weak signal. So you need to amplify the signal, you need to filter it, and you also need to convert it to digital. Because our microprocessor is digital. So that's why we are making sure that we convert the signal to digital, connecting via a serial If it is a digital, there's no need to convert. We connect straight with the serial. Other subsystem, here is just an I/O, is the inputs, outputs. And also we've got the actuator with the pulse width modulation, which I said the lab that was having the issue of the brightness, that was varying the brightness. It was using pulse width modulation because you're not trying to vary to increase the power, or you can increase it if the satellite is going out of orbit, that kind of thing. So this is also just showing you that different sensors, they can be connected to our command and data handling. At the same time, we need memory, because if the satellite is taking a picture, it needs to store. If you are not in the visible range, it needs to store somewhere so that when you are able to have communication with the ground station, it needs to send the data. So we've got data memory there. It is also connected via SPI. I think my colleague, he also highlighted the issue of the power being powered to the memory. Okay, so there's a very important thing that in design you need to make sure that you select a component that is able to satisfy your requirements. In the first presentation, he highlighted a very important thing that you need to define your user needs. What exactly do you want? That will make you, okay, I think I need something with this kind of amount of power to be able to fulfill this kind of mission. So which means you need, maybe if it is something to maybe to require maybe some video or something, you might need to require more computer processing power, computer processing unit. Then at times, you need to store the information permanently, which means you need read on. At times, you need to store your information temporarily, which means you need the random access memory. So those kind of things, they are very much important, because if you have a mission that requires less data, then you know that, okay, maybe I don't need too much from, I need this kind of from, because I don't need more data, depending on your mission. So the choice of the command and data, and since it is the brain, if it is very weak and your mission requires a very robust system, then it means you need to make sure that you take that into consideration. Okay, then when you choose your components, starting from the user needs, go to the system requirements, component level, you need also now to go on the other side to check, okay, this component, like what you were doing, you connected your power to, you connected the battery to the board, and you put the power, you tested, okay, is it on, you verified it was on. Okay, connected the solar panel, you went to the projector to check with the light. It's almost the same. You need to go to verify, because when you send your satellite in space, you don't have time to go there and try to fix the problem. So we want to make sure that we close the loop and make sure that we have our test, so that when we launch our satellite, we need to make sure our mission is very successful. So that is very much important. So in terms of command and data handling, we need to check to apply adequate volume. Is it necessary? We need to calculate whether it is able to store the required amount of data since you've done the calculations to test. You need to test that. You also need to test the handling command. Is it able to process the communications from subsystems? Here, if I send a command from the ground station, is it able to communicate? Is it able to do that? If you have your sensor, is it able to communicate with the sensor because it's connected to a certain pin? Is it responding? So you need to verify all those kind of things that will be connected to your command and data. So, issue of power was well explained by Professor Mustafa. The battery voltage, as you connected your power to your or to your HEPTA-Sat. That voltage is very important. Also, the satellite is in space. We need to know the condition of the satellite. Is the satellite well? The health of the satellite, which means we need to know your battery voltage. We need to know the current. We need to know the temperature. Is the satellite okay? Before it even sends the data, you send the command, okay, is the satellite okay? They're supposed to respond, yes. It gives you the information, the battery, the voltage. So you need to monitor the condition of the satellite. Which means in the labs that are coming, you are going to test. Now you have connected your power. You're going to test, is the voltage okay? Get the condition, do some programming. So expect that kind of exercise in the next couple of times. You also at times need to reset. Maybe you want to reset the satellite whilst you're on the ground. Because you can't go to space, you need to do it on the ground. So those kind of tests, they are very necessary before launching the satellite. So I think in terms of issues to do with command and data handling, yeah, that's it. But persons are welcome so that at least that two-way communication is very necessary. If there's anything that you want me to clarify, yes, I can do so. If I can't, some of my colleagues will also help. Thank you.
Okay, just this is the last lab for today. So let's make it happen until the end of the day, okay? All right. Tomorrow morning we start with a new lab. Okay.